Okay. If you have a calculator handy, could you calculate this value for us, please?
Yes. Hold on. 21 sine 61. 18.36. And then
So I got a
divide.
different number. I got a different number here. So I mean, it's close, but not. I mean, I wouldn't say that close. Let me make sure. So 21 times sine of 61 over sine of 71.
I got
There we
19.4.
go. There it
Yeah,
is. Yeah,
I
19
wasn't.
point.
Yeah,
Perfect. Okay. Awesome.
sorry, I didn't divide by the 71 yet.
Okay. Got it. Yeah. Okay, so what's good here about this problem is that you see that you can use law of sines to find the side. Now I know as a student, sometimes you want to map out these rules. If you really want to rule here, like 2 of the angles were given and a side, that's not perfect because that could also be, you could also maybe think of something else, but that's what you're looking for law of sines. But I sort of prefer this angle side across from it pair that you've got.
Gotcha.
Any questions on that?
No.
Okay. So the other time that you use law of sines is to find the angle.
Okay.
Like I showed here in this sort of flow chart, you either use it to find a side or to find an angle. Excuse me. Let me snip in this question here. So here's another triangle. And notice they only give you one angle.
Right.
There's no way to find the other 2 angles by simple subtraction. You have to use law of sines.
Right.
So you have to decide, okay? And I'll choose for you here. Well, actually I take that back. You can only find R in this problem because you have the side across from it. So Matthew's preference is always to put the sign or the thing you're trying to find in the top left.
Okay.
So this time it's angle on the top, side on the bottom.
Mhm.
So you need the side across from R,
Which is 15.
15.
Why can't we solve for? Oh, because S doesn't have a other. Okay.
Yeah, it's a good well, why can't we? Well, it's missing too much information for that. Good. Now on the right here, you need another angle and another side. So you have to use the only one that's given.
Right.
Sine 98 over 17.5. Now, you've probably noticed that I am not writing out the formula each time. I'm not writing like sine A over A equals sine B over B. I'm saying angle over side. It's really the sine of that angle, but equals angle over side. If I find formulas, while this one's not hard to remember, it's just sometimes it's better to remember the words or what they mean. Like, what is the sine of A? It's an angle and a side across from that angle.
Got you.
Okay. And my preference is always put the thing we're looking for, the thing we're trying to solve for, in the top left.
Mhm.
Okay, so we undo by multiplying by 15 on both sides. So sine R equals, and really better to put that 15 in front, 15 sine 98 over 17.5, like that.
Mhm.
And then how do you undo sine? Use sine inverse. Now your calculator can handle all of this in one step, or you can put this all in at one time and get a final answer. If you want to piece it together, you can, but know that your calculator can do all of that. So go ahead and work that out on your calculator and let me know what you come up with.
I got 58.8.
Yeah.
No, 58.08. Sorry. No.
Yes.
Yes. Okay.
We'll say 58.1 degrees. Okay, so let me, obviously I've got the luxury of being able to copy and paste here. Let me copy this picture down and label R 58.1 degrees. How do we find angle S at this point?
We add up 91 and 58.1, right?
Okay, could you do that for us?
58.1 is 156.1.
Okay, what's the missing angle there?
The missing angle is 23.9.
Okay, very good. So let's say we wanted to find Y. Why do we use law of sines here?
Why? Because we can
Yeah.
use the. Can you ask the question again? You kind of cut out.
Yeah, why do we use law of sines to find Y? What is it about? Why does law of sines apply here to find Y?
Um, because you need an angle or a side to find an angle or a side. And since we have an angle, we can use that angle to find side Y, right?
Yes, sure. Yeah, no, that's perfect. Yeah, I mean, that's exactly what you need to say. So the thing we're looking for is Y over. Now, Y is a side, so we're going to go sine of the angle across from it down
23.9.
here. Yeah. And then you have a choice here. And what I always tell students is to use the given information, not the calculated values.
Right.
There's the potential for some error. It's not enough to worry about, but it's possible.
Enough.
Yeah, you'll be careful with that. Whenever you dimension drawings, you always dimension from a known sort of a known place, not a calculated place, if at all possible.
Got you.
So you're just solving for Y here, so you got to clear out this sine 23.9. You probably already know how to do that. That goes in the numerator. Sine 98. If you got a calculator handy, please go ahead and calculate that. It is pretty important to be able to get the calculation right.
7.16.
Yeah, you're a little faster than me here tonight. Yeah,
Sorry.
good. That's great. 7.16. And then what about units? This one actually has some units on it.
Would it be 7.16 meters?
Yes, got it. Okay. Let's look at a couple more problems here, but we don't actually need to do the calculations. I want you to just set up the problem, meaning like you've got to tell me what you would solve for.
Yes, sir.
So let's take a look here. Here's a new question for you to look at. I want you to tell me using law of sines what you would solve for, and then what you would and how you would write it out, what your equation would look like.
We'd start off solving for I.
Okay,
So,
angle I. So go ahead and take a moment and figure out what that would look like.
I over, no, yeah. Sine of I over 8 and then equals sine of 115
Okay,
over 13.
very good. Okay,
Then you would multiply by 8 on both sides.
right. And you take the sine inverse and you'd get I.
Yeah.
Good. Okay, so once you found I, what would you do to find H?
You could add up all the angles you have and
Okay,
subtract it from 180.
got it.
And then after that, you would find side GI by doing sine H. No, by doing GI over sine H equals
Yeah, you're doing great. Keep going. You need another side up here. Side over angle.
over equals 13 over 115 sine. sine 115.
Perfect. Yeah, that's really well said. I mean, that is the mapping that you need to be able to do to solve for the missing side there. So let me give you one more just to have you look at. Same thing here though. You don't need to solve it. I just want you to look at it, interpret it, say, okay, well, like when do I use it and why? What can I solve for and why?
So here we would here we would solve for AC using angle B, right?
You
So it'd
could absolutely
be
do that. Yeah, you could
so
absolutely
it'd
do it. So
be
let's call it little b. Yep. So b
right,
over.
B over sine 51
Okay, equals
equals 9.8 over 71.
sine 71.
70 sine
Good.
71.
Okay, so assume now that's perfect. Now assume now you have b. What could you find next?
Um, we could do Pythagoras to find. Oh no, you could add up the
Yeah, this is
two
not a right
angles
triangle.
inside.
Yeah, you got to be careful. It's not a right triangle. Yes, you keep going. You add up 51 and 71.
You add up 51 and 71, and then you subtract that from 180 to
Okay.
find big C,
Okay,
and
so
then we
that's
would find
58, I believe. Okay, so now that you have big C, what can you do to find little c?
um the kind of the same thing you did with little b. It would be little c over sine 58
Okay, keep going.
equals 9.8 over sine 71.
Very good. So this is exactly what you just did is exactly how I used to study in college with classmates and certain things for tests. We wouldn't necessarily have the time to like work through all of these problems, but we would do exactly that. Like if I found B and then I found this, how would I find this? And that's what you just did here. That's really good. It's really good to be able to talk your way through a problem like this one. Okay.
Right.
So we could talk quickly about law of cosines or move on to another topic. What would you like to do?
Can we talk about law of cosines, please?
Yeah. So I think law of cosines is a little bit straightforward in terms of what you're looking for. You're either
Right.
looking for all three sides are given, or you're looking for side, where the angle is between the sides. Okay, so let's
Yes.
look at a side case.
Okay.
Okay, so here we go. All right, so here we go. Here's a picture. All three sides are given. And what you may want to do is draw like a reference triangle.
Mhm.
I hope this is okay. Usually the angle is C. I mean, you can call it C that you're solving for. That's kind of the traditional case. So the way this is set up is it's Pythagorean theorem. It's C squared equals A squared plus B squared. That's the first part of the formula. Minus 2, and then it's the same letters. So if you got A and B, they go here.
Right.
Cosine of the angle across from whatever this letter is.
Cosine C. Okay.
Yes. Okay. Now, I mean, I probably know this for the rest of my life, but I want you to know that the way I learned this is I recognize the pattern. Like whatever two letters are here also go here. Whatever letter is over here on the left, the big letter goes over here on the right. And the angle is always between the two sides. When you look for patterns, that's how you remember these formulas without remembering the formulas.
Okay.
So we should then substitute in numbers probably. So that's 13 squared equals 9.4 squared plus 7 squared minus 2 times 9.4 times 7 cosine big C. This is the
Mhm.
step where most mistakes are made, mostly from the calculator. You're subtracting that 9.4 squared, and then you're subtracting that 7 squared. equals -2 times 9.4 times 7. You can calculate here. And a lot of students do. I wait until the end, but you can absolutely calculate these along the way if you want. You're going to divide both sides by this -2 times 9.4 times 7.
Okay.
Okay. Now, while your calculator can do even the final step, this is probably a good place to get a number in your calculator. Just be careful. You need to have parentheses around the numerator and then another set of parentheses around the denominator.
Yes, sir.
So go ahead and calculate that for me. I'm going to do the same, and hopefully we come up with the same number.
Hopefully.
It's always good to do these calculations twice. You know, clear out your screen, try them again, and hopefully they're the same. If they're the same, you either got it right or you made the same mistake twice. Hopefully it's that you got it right. What did you let me know what you come up with here for this.
Yes, sir. 9.4, not 9.8. Um,
If you have questions, I can pull up my calculator and show you also.
I got negative 0.24.
Keep going.
0.42555319.
Yeah. Okay. Yeah. So you got to go a little ways with that for the next step. Okay. And from here, you just take the cosine inverse of both sides. So maybe you're familiar with using A and S. I'm not sure if you're familiar with that, or you copy and paste, but you want to use a fair amount of precision on that, like 4 to 6 decimal places. That will give you the best result here.
Right.
And if you have no idea what I'm talking about, I can show you examples.
No, I get what you mean.
Cool. So I get C is about 104 degrees.
I got about 104 as well.
Great. Okay, now let's go back to our picture here, because this is really important now that you've found the angle. Okay.
Right.
So I think I might have mentioned this before, but you only use law of cosines once. Like you don't have to keep using it.
Because we can use
And
law of sines twice.
exactly, or use law of sines, because law of cosines is more complicated than law of sines, and because you now have these paired up, side and an angle. Like if I wanted you to find angle B, how would we do that? How would we set that up here? Using law of sines.
We do sine of B
Okay,
over 9.4.
good.
And then sine of 104
Okay,
over 13.
okay. Now you do all that and you get B, and I don't know what it is, but let's just say it's whatever, 36 degrees or something. How would
All
you
right.
find angle A?
Adding up the
Yes.
angle B and angle 104, and then subtracting that from 180.
Exactly. Exactly. So try to think through that if you get it presented with a question like this, because the last thing you want to do is like use law of cosines again when you don't have to. You only have to use it one time.
Right. Okay.
A lot of students don't recognize that. And a lot of teachers don't tell you that. They just let you, do this. It's like, no, you don't have to do that. Okay, so the second law of cosines case is when you're given a side angle side.
Mhm.
So notice you're given a side, and the angle has to be between them. That's really important there. Has to be between.
Is there ever a case when it's not in between? Like,
So let's imagine for a moment the angle is here. Would this be a law of cosines problem now?
No, because you could use a lot of signs.
Yeah, you gotta, yeah, so that's the only, that's why it has to be, the angle has to be between for you to use law of cosines,
Okay.
right? So now let's write out the formula, but sometimes it's good to actually draw like a reference triangle next to it. So let's see here, let's call this big angle C, A and B. So the first part of the formula is the C squared equals A squared plus B squared. That's the Pythagorean theorem, just sort of written in different direction.
Right.
Minus
Right.
2AB because A and B are on that side. Cosine of big C.
Okay.
So in your problem, you're trying to find X, so it's X squared equals, and the A or B doesn't matter. It doesn't matter whether that's A or that's B. You just pick. It really won't matter.
Right.
Cosine of 61. And so you just calculate this. Only thing you got to be careful of is okay, you get all that number, but then do you take a square root? Don't forget to take a square root to solve for, basically, because you'll get a number that's really large, and it should be in the same order of magnitude as these numbers when you're all
Right.
done.
Right.
So if you grab your calculator if you got it, and let me know what you come up with.
Whoa. Oh, right. It's a big number.
Right.
53.465.
Yes, exactly. Yeah, 53.465, we'll say. That's good. Got it. So let me grab the triangle again here, and then grab this here. There it is. Okay, so we now found that this side is 53.465. We used law of cosines.
Right.
So let's say I wanted you to find B. How would you find angle B?
Um, I would do law of sines. It'd be sine B
Okay,
over 55
okay,
equals sine 61
okay,
over 53.465.
good. Fantastic. Now let's just say you worked that all out. You found angle B. How would you find angle A?
Adding up angle B and angle 61.
And subtracting from 180, right?
Yes.
Really good. So that's really good. Like that progression is really important, that you see like, okay, I do law of cosines, but then I don't have to use it again. I can use law of sines, and you know why you're using law of cosines, why you're using law of sines. That's a much more important part of math that you're getting to. You need to know why you're doing something, not just how to do it.
Yes, sir.
Make that connection. So that's really it. I mean, other than just doing a million problems, I mean, that's really it. There is the exceptions. There's no triangle, and then there's the, I don't know what they call it in your class, but there's when there's multiple triangles or no triangle. I wouldn't think that would come up on a final because it's kind of a exception, but
I mean, he did have a test question on it last time, so maybe.
okay. It's but so in terms of what we're going to cover, I don't think that's a good use of our time. If there's probably some other
Right.
things you have questions on,
Right.
you know, the when you use it is okay. What you should be looking for is when you calculate an angle.
Mhm.
It's usually law of sines, by the way. It's usually law of sines. Whenever you calculate the angle, if you take 180 minus that angle, and then I call it, there's still room for the other angles. That's how you know. And without doing an example, we wouldn't be able to get into it, but it generally comes from law of sines and first finding the angle.
Okay.
Missing angle. But we should talk about some other things. What else comes to mind from the last few weeks that
Can we do some right triangle trigonometry?
sure, it's a good idea. All right. Okay, so let's say I give you a triangle like this. And let's see, I tell you that this is 5 and this is 13 and this is A and this is B. I want you to first find little a here. So it's a right triangle, which means that some of the things, well, not everything almost nothing we just did applies. The things you have here are Pythagorean theorem, and then just regular sine, cosine, and tangent for this. So do you remember how you might find letter A, the other leg of the triangle here?
Normally Pythagoras, but this is
Yes,
a Pythagorean triplet, so it's 5, 12, 13.
exactly. And you should be on the lookout for those. That's great. I choose those because they're easy to do. And we'll do some examples where it's not. So now let's say I wanted you to find the sine of A. What two values do I need for the sine of A? What's the ratio in the top and the bottom here?
Opposite over hypotenuse, so it would be 12 over 13.
Good. How about cosine A?
Adjacent to hypotenuse, so that would be 5 over 13.
Good. How about tangent of A?
5 over 12.
Yeah, now
Opposite over
notice
adjacent.
it's also sine over cosine. So if I write 12 over 13 over 5 over 13,
Mhm.
and then you cancel the bottoms because you're allowed to do that, you get 12 over 5.
Right.
That's consistent with what you just said. Now, have you guys been doing like cosecant A?
Can you
Do you have
say that
any idea
again?
what? Have you done cosecant of A?
Yes, that would be
Okay,
13 over 12.
13 over 12. Okay, how about sine A? I'm sorry, secant of A?
13 over 5.
13 over 5. So notice when you do them in the right order, sine, cosine, tangent, and then cosecant, which is reciprocal of sine, secant is reciprocal of cosine, you just get it. You just get it there. Now, cotangent of A is the reciprocal of tangent. It's also cosecant over secant, whatever
Right.
that's worth, but it's probably easier done as the reciprocal of this, which is 5 over 12. Okay, so those
Right.
are the nice ones, right? That's a nice one. Let's do one that's not so nice. All right, let's make a slightly different triangle. So let's say that this is the square root of 15 and this is 1. Could you find side C for us, please?
One sine of 15. So you would do Pythagoras, that'd be
Yes.
1 squared plus 15. 1 plus 15 equals C. So C is 16. No,
C squared
that would
is
be
6.
C squared. So that would be 4 for
C is
C.
4. C is 4. Very good. Oops, just a little lag here. C is 4. Good. Okay. Now let's say I wanted you to find the sine of B.
You do opposite over hypotenuse, which is sine of 15 over 4.
What goes over here? What goes in the numerator? The 4 goes down there. I didn't hear this.
Sine of 15. No,
It's
not
the
sine.
square root of 15.
That thing, yeah. Square
Yes.
root of 15.
Yeah, I heard something else. That's okay. Cosine of B, what would that be?
1 over 4.
4, very good. And then tangent of B.
1 over the square root of 15.
So you have them, tangent is opposite over adjacent. You've
Oh,
got
so
those flipped there.
My bad. So
Okay.
b square root of 15.
Yes. Okay. Now this is where it gets a little bit more challenging here. The cosecant of b is 4 over root 15, but there's a problem with what I've written potentially. Most instructors want you to rationalize this. Do you understand
Right.
what I mean by that, or is that?
Yes. You mean to multiply by like the square root of 15 on both top and bottom to
Exactly.
even out the denominator?
Yeah, and one of the things I find frustrating here is it actually looks worse. Like when you're done, it's 4 root 15.
Over 15. That's just weird.
Yeah, it's not, it just isn't nicer.
Yeah, it's just weird.
Secant of b, that's
It's
the
just
flip of that,
4.
4 over 1. And then you get the same problem down here, cotangent of b, 1 over root 15. So you have to rationalize that as well. So it's root 15 over 15.
Something like that looks more acceptable than 4 root 15 over 15.
Yeah, yeah. And I mean, these are just the rules. So
Hmm.
okay, let's grab this triangle here and let's just do a couple more things here. So one of the things I have not had you do is actually find the value of b.
Oh
Find
yeah.
the value of b. Like we just said, we're like, all right, sine b is square root of 15 over 4. But what is the actual angle measure of b? So that's where you do the sine inverse of square root of 15 over 4. So could you do that for us? Could you
Yeah. 1 second. Oh my god. Divided by 4. 75.52.
yes, that's correct. So 75.52. Now let's say I wanted you to find angle A. How would you find angle A? The simplest way possible. What's the best way to find it? Easiest, fastest.
Sine.
Just like in the
Right?
previous problems, what do the three angles in a triangle add up to?
Oh, 180.
Yes. So you don't want to overlook that, because like you can do an unnecessary step to find it. Now we know the answer is 14.48. But let's do something different here. Let's use the sine of A to find it. The sine of A is 1/4. So A is the sine inverse of 1/4. So would you put that in your calculator and verify that that actually is what we think it should be, which is 14.48 degrees.
I got 14.477, which rounds up to 14.48.
Yeah, close enough here. Yeah. So it all should work. Like it should never violate each other. If it violates, you've done something wrong, you made a mistake somewhere, something like that.
Right.
Okay, now did you have any word problems in your in this part of the course? Right angle, trigonometry, word problems, story problems, like ladders or airplanes, anything like that?
Word problems. I think so.
Okay.
Hold 1 second. The tallest tower built before the era of television mass, the Eiffel Tower, was completed on March 31st, 1889. Find the height of the Eiffel Tower before a television mast was added to the top using the information given in the illustration. And it's like 80 feet on the bottom,
Okay.
and then 85.36.
For what, the angle or
The angle where your cursor is at currently. Yes, right there.
like that? Okay, we need to find the height.
Yes.
Okay, yeah, I mean, I can make some more of these up, but yes, this is perfect. I mean, notice like it didn't really matter what you were saying. Like it's a triangle. Like don't overcomplicate like where if you're in the part of the course where you're doing triangles, you need to draw a triangle. And you're labeling some part of it. Okay.
Yes, sir.
Now relative to this angle, you're given this angle right here on the left,
Mhm.
lower left here. What is H and what is 80? And your possible answers are opposite, adjacent, and hypotenuse.
Based on the angle given, 85.36, H is the opposite,
Okay,
80 is the adjacent.
very good. Now, which of the three trig functions, sine, cosine, and tangent, uses opposite and adjacent?
Tangent.
Okay, so that tells you which one you're using. That's critical here. So it's the tangent of 85.36
Mhm.
equals opposite. What is opposite? Oh, it's H. What is adjacent? Oh, it's 80.
Right.
And then how do you solve this for H?
You take the inverse tangent of, well, you take the inverse tangent of 85.36.
What
No,
what
wait,
no,
you're solving for H. You
solve for H,
multiply
yes.
by 80.
Perfect. Yeah, that's right. Good.
And that would be, oh, that's a big number. 985.697.
Yeah, so we'll say it's about 986, meters or feet or whatever it was given in that problem.
Right. It was in meters, I believe.
Yeah, so your
In
instructor's
feet.
probably looking for units, so just confirm that.
Right. Right. Okay. That was,
Okay, so let's do another problem. Let's do a ladder problem. So maybe you're hanging up lights on the side of your house. Maybe you're doing it for a friend, but he's got a 21-foot ladder.
oh my.
Yeah, actually that's not drawn very well. It's drawn a little different. He's got a 21-foot ladder
Mhm.
and it's only 6 feet. It's only 6 feet from the wall.
Okay.
Okay, so I want you to find this angle right there. That's called the angle of elevation, but how do you find that angle of elevation? It's the same thing as last problem. You have to figure out relative to that angle, what is the given information? Is it opposite, adjacent, hypotenuse? Which two of the three is that?
The angle right now relative to that angle, it is adjacent and hypotenuse.
Okay, so which trig function do you use for that? Sine, cosine, or tangent?
Cosine.
Cosine. So we have the cosine of theta equals what over what?
6/21.
Good. Well, I want you to solve for theta. Give me your final answer rounded to 1 decimal place.
Um, rounded to 1 decimal place.
Yep, give me 1 decimal place.
0.3.
I want the angle. The angle's not 0.3 degrees. The angle's a lot more than that. Did you solve for angle or did you solve for the cosine of theta?
Oh, cosine of theta. I forgot to do the inverse.
Yes.
My bad. Mm. Um, Inverse cosine would be 73.4.
73.4 is correct. Very good. Okay, so before you answer this next question, really try to think real hard about doing this the easiest way possible, meaning and there's actually 2 approaches, but I want to know the height of the house.
Easiest way possible to find the height.
Well, that's not quite fair. There's 2 approaches. I'll take either of them to find the height.
Well, in that case, it'd be 6 squared plus 21 squared.
Well, hang on
No.
a second. It's
Wait, hold on.
it's
No,
yeah.
it's 6 squared or 21 squared minus 6 squared.
Yeah, no, I like to write it out. A squared plus B squared equals C squared. So that is option one. That is the first way to do this for sure. And I think that's the easier way. Option number two is to use some variation on sine, cosine, or tangent.
Mhm.
I think they're equally right here. I wouldn't have an issue with either one. It's kind of preference. But yeah, because you could solve for H in this other over here.
H is 20.124
Yep,
according
perfect,
to option one.
perfect, perfect.
And
Now
then
let's do it with option two, and excuse me, let's use sine. Let's use sine 73.4 equals H over 21.
right,
Like you to solve that for H, and you should get exactly the same answer.
so 21 times sine of 73.4 is 20.124.
Yes,
So
exactly the
20
same.
yeah, exactly the same.
Awesome. Okay, so the time we have left, let's quickly talk about reducing roots. So let's say you do Pythagorean theorem and you get the square root of 80 as your answer. Do you recall how to reduce this root?
Yes. So you would split it into parts that are easy to uh
It's
square
called
root.
it's called a prime factorization. The approach you're about to mention it's kind of it works sometimes. The prime factorization is key here. So that your prime numbers are 2, 3, 5, and you don't have to get much bigger than that.
Right.
But you always start with 2. Does 2 go into 80? Yeah.
Yes.
2 times 40, 2 times 20, 2 times 10, 2 times 5. So you stop when you get there. Now, the approach, I'll talk about the approach you were about to give. So for each pair, you bring a number out. So you
Right.
bring a 2 out and a 2 out, and whatever's left over stays on the inside. So you get 2 times 2 square root of 5,
Okay.
which is 4 root 5.
Right.
Now, the approach that I think you were about to tell me is like you look for the biggest perfect square that goes into 80,
Yes.
and it ends up being 16. Now, I mean, if you know that, that's very impressive because a lot of students just would never be able to figure that out. The problem is if you don't guess the biggest one, you have to keep doing it. I don't like this approach, but they both work.
Right.
Because the reason you do it is because the square root of 16, it's like, oh, that's 4 root 5. And these are exactly the same.
Right.
So the approach that the approach that you mentioned works really well for something like this, the square root of 300. Because
Yeah, that would be
it's the square root of 100 times the square root of 3, that's 10 root 3. Whereas building a factor tree, like 2 and 50, 2 and 75. Okay, 3 goes in 25 and 5 and 5. A lot more work.
right.
So they're both reasonable here. You just have to kind of pick the one that works best in the situation. I always use the one on the left, but I understand why the one on the right would be good. The reason I bring that up is with Pythagorean theorem, sometimes you're taking the square root of a number you don't know. Consider.
Right. Okay.
But that is it for us for tonight. If you do need another lesson for your final, just you have to schedule that through the website or have mom contact me to do it manually. But hope you do well. I think what I heard tonight, I think you really understand the material.
Thank you.
And I look forward to helping you next semester if I don't hear from you between now and then.
Awesome. Thank you.
Yeah, you're welcome. Hope you have a great rest of your night. That is it for us for now.
Awesome. Have a great week.
Okay. Yeah,
Bye
bye.
bye.